All right, welcome everyone. It is 9 o'clock, so we'll go ahead and get started. People will continue to join, and that is just fine. My name is Christy Gagne, and I'm a program manager for Telehealth Rocks. Just a little bit about us. We are a federally funded program that focuses on school-based behavioral health. And we do this by working on social determinants, supporting school-based services, and telementoring trainings just like this one. We have some Telehealth Rocks team members here today, Robert Stiles, Haley Bell, and Chase Koob, and they're here to help. They might be putting items in the chat or responding to questions or chiming in during the session. Feel free to reach out to any of us if you need something during the session. We're glad you're here to discuss brain development and student behaviors, and we've got just a few notes for you. So this session is being recorded, and we will send it to you afterwards. Your microphone has been muted, and you can use the chat to unmute or ask any questions. Make sure that your first and last name are visible on your Zoom screen or that you've typed it into the chat so that we can track attendance for your certificates. We don't have any disclosures, and everything presented is evidence-based and currently accepted within the profession. And then after the session, like we mentioned, we'll share the slides and recording just as soon as we can. Give us a little bit of time to process that, and then watch your email for it probably tomorrow. The certificates of attendance will be emailed after the series ends, so we will track attendance through the series and then email that to you. And then if you have any questions, please feel free to email us at telehealthrocks@kumc.edu. All right, let's get started. I will hand it off to Stephanie and Evelyn.
Thanks, Christy. Good morning, everybody. It's really great to see so many new and returning faces online. We're really excited to move the series forward. Next slide, please. So just to give you an idea of what we're planning to talk together about today, we really appreciate the input folks provided at the last session. So what you'll see today is really guided from some of the advice and priorities we heard from you all. We're going to talk first off just about putting our intentions into practice. We'll talk about neuroanatomy and especially paying attention in memory today. We'll talk a little bit about reduced access to resources and trauma impacts on our brain circuits. We'll talk about applying neuroanatomy to self-regulation. And then finally, we'll learn a little bit about ways to talk with kids about their brains and this really cool idea around construction zones. Next slide, please. So this is just a reminder slide for our whole series. We're really leaning into the idea about intention setting helps kids and adults organize information. It really gives us a structure to allow us to become active learners. So that's what we're going to start off with today, talking a little bit about the intentions that were set last time and really hearing from everyone about what worked, what didn't work, and how can we talk together to help one another put things into practice. Next slide, please. So we'll start together by asking for your help. We'd really love to hear something from the last session that you told us that you had hoped to put into practice between now and meeting together today. So we ask you to type in the chat box what was the most helpful thing put into practice from the last session. It's a-okay if that changed from what we talked about that day and may have been fine-tuned or kind of something that you just kind of put into practice after the session too. We gave a couple of examples that we heard at the time, just really to emphasize it can be a small intention. That's a-okay and awesome. It could be sharing one brain fact with students between now and the next session. So I know we're lucky to have new folks joining us today too. So we'd love to hear from you as well. It's great to hear what is one thing you were able to do to help calm your brain or de-stress. So with that, we'll give you a few minutes. Seeing that lots of folks are already typing things in, I super appreciate that. We'll take a couple minutes here. We'll move to the next slide as folks continue to enter information. So first off, we're talking about what the intention was, and then in this next slide, we'll talk a little bit about what helped or got in the way. So again, let's just take a couple minutes with intentions, and then we'll move on to kind of what helped or hindered.
I just appreciate seeing all the different ways you've thought about this, used this information since we met last. It's really cool to see.
It's really cool to see the range of different things too. So well
Mhm.
done, everyone. This is really great.
Yeah. I always find it fun to kind of see just right when it's more interactive as a group and kind of just, even though we're not hearing, we're seeing in the chat box, there's all the really cool ways that you all are incorporating this information already. So that's just find it pretty cool. Hey, I see lots of reducing multitasking. Good job. Good job. It's so hard to do.
Yeah, that's not an easy one.
Mm-mm. Yeah, I see a lot of you also are sharing the brain model with the kids, right? Or using it as like a starting, like a talking point. I think that's awesome. And I think it's really cool too, just to see how curious kids are, right, about these things. That's awesome. Using the emotion regulation language or brain knowledge to talk about emotion regulation. That's awesome. Hey. Yeah, well, definitely, if other thoughts come up, um, we can have you guys share. Anything else you wanted to add, Evelyn?
Um, Again, all these are awesome ideas. I think that if there's any guidance about with implementing the ones we see all in the chat, if anything really helped out and made it possible to share, or also if there was anything that really got in the way of putting something into practice, um, folks may have gone to plan B or C or D in what they were doing. So if there's any guidance that way about things that helped out or got in the way, we'd love to hear that too.
Yeah. And just want to honor too that with trying new things, especially in a busy classroom environment or even with ourselves and our own busy schedules, like it takes a lot of extra mental effort. And so just wanted to say, we definitely see in our, reading just all the different things that you're doing and just want that to go, not unnoticed that it does take a lot of extra mental effort to do the things that you're doing. So we definitely appreciate you, just your willingness to try things out.
Thank you for folks filling us in too. It sounds like there's a couple of folks who haven't received their brain model. So just that's really helpful for us to know so that we can work with Christy and the team to help us circle back.
Yep. We'll help you problem solve and figure it out.
For sure. I think with that, we really are encouraging folks to keep in mind as you listen to the content today, just what intention you may want to set at the end of this session. Um, and then just really encouraging as you have thoughts throughout, we really love to hear from you in the chat or unmute, just to make sure that we're hearing your priorities and thoughts as we go through the session today.
Yeah.
We'll go to the next slide.
Yay. All right. So my favorite part. For those of you who have the model, if not, it's okay. We can definitely, once you receive it, if you have questions, I'm more than happy to help answer questions about stuff. But thinking about our brain, this is pretty close to life size. It's not, but it's pretty close. And looking at, there's lots of different parts, right? And if you look at the diagram on the slide, things are kind of put into lobes or parts. Whereas this, right, it's kind of hard to see because everything looks like this giant kind of pink blobby mess. So how we kind of talk about the brain, right, is we try to section things off into these different lobes, if you will, or sections. The reason why it's really important to kind of know what these different brain parts are is that it can help us kind of talk about things and also help explain things to others and also have a better understanding of kind of what's happening for us in the moment. So this will all make sense in a second, I promise. But to kind of go, okay, this is the brain. There's a lot of different parts going on this slide. The front part is what we call the executive or frontal lobe. That means all of our planning, organizing stuff that happens that kids maybe aren't the best at, that's that front part right there. There's something called the parietal lobe that tells us where things are. It's how I don't bump into walls all the time, or I know where the tip of my nose is. Temporal lobe, I'm talking to you right now. So that's actually this side piece right here on your brain, or that yellow section on the slide. And that's all our language, being able to understand, hear it, use it, produce it is there. The back part, very, very back of my head, if I tie my hair back, kind of where that hair tie usually is, that is our occipital lobe. And that's a lot of vision stuff that happens there. And cerebellum is important. It's kind of, if you were to stick your hand behind your neck, it's kind of where the top part of your hand under your head is going to hit. That's where your cerebellum is. That's all important for balance and coordination of movement, and also coordination of thought. So we can see a lot of different sections, right, on this pink structure that are really important. And so if you think about when it comes to kiddos, things like, especially little itty bitty kiddos, the cerebellum, the back lower part of our brain, that's not fully formed yet. Like it's the structures are there, but they don't have all these highways branching out yet. And so that's why when you see little kids start walking, they look super what we call ataxic or not really coordinated in their walk. And that's because their cerebellum isn't quite online yet. It's a construction zone. When kiddos, you see them kind of do one thing and then go to the next toy and the next toy, that's because the front part is a construction zone. Things aren't quite, they don't have their super highways going to the different areas yet. So it's kind of cool to think about, right? In our adult brain, we have lots of, areas that aren't really under construction at any given point, but for kiddos, it's like there's tons of construction zones, and we'll get into that a little bit more. Now, for those of you who have the brain model, we open it up. You can see the inside. So even though there's a lot of stuff happening on the outside of the brain, there's also lots of stuff on the inside that we can't see as easily. So important things, if you look at the right part of the slide, important things in the center, there's something called the thalamus that does nothing but sensory information. So a lot of emotional stuff's also tied to that. The amygdala, which it's itty bitty on here, but it's here near this purple structure. The amygdala is where a lot of our emotions come from. So again, that's where our fight, flight, freeze stuff comes from. Whenever we get kind of that internal activation where we feel kind of restless on the inside, that's all coming from this little warning system in a sense, the amygdala. The hippocampus sits right next door to the amygdala, and that's where all of our memory stuff happens, memory storage in a sense. And so it makes sense, right? When all this emotional sensory stuff is right next door to the memory piece, that's how we have like those flash bulb memories, or like where something really intense or happy happens or sad happens. And we can kind of put ourselves back in that moment and remember things exactly the way it was. And that's because the amygdala is right next door to the hippocampus. To me also, by knowing, the more we know about the brain and kind of there's different parts, they all work as this big circuit. It makes it also too, like as some of you kind of alluded to in the chat box, that makes it less of a mystery as to why things are happening. It can also be used to kind of help decrease shame or blame around someone's inability maybe to focus, right? You thinking about especially kiddos, even kiddos with ADHD or other kind of attentional vulnerabilities, thinking about how, it's like we have the language and we can kind of show them with our models, or just think about neuroanatomy stuff and be able to actually help the kiddos explain and know kind of, right, remove the mystery piece to it. It's like we know why this is happening, and helping the kiddos also, right, kind of learn this is why the regulation strategies, right, might work, because it's tapping into some of these pieces. Next slide, please. All right, so we're gonna have you guys do a poll. And we're curious to see what brain models are you all using? There's no right or wrong answer here. We're just kind of curious to see what you're using. Okay, we'll give you a couple more seconds to answer. You guys are doing a great job. I appreciate all the participation. Yay. All right. Let's see. Should we go ahead and share those results? All right. Yay. So I appreciate kind of knowing kind of where you all are at in terms of what's what you're using to explain things. I think the hand model um is a great way to kind of be able to without you don't need anything else but your hand to kind of explain to kiddos or to parents too, kind of what's happening in the different parts. And if I'm not mistaken, the thumb is kind of like the amygdala piece, and that's 100% correct, right? Because if you think about the brain, it's inside all of these things. So I think it's a great quick strategy to kind of show the amygdala is the one that's kind of going off or having a lot of is having a difficult time right now. I think it's a great way to talk about things. Yeah, all right, let's go ahead and move on to the next slide. Oh, I appreciate y'all's comments too about there's other models. Yeah, definitely. If you use other models that we didn't list, please feel free to add those in the chat. Yay. Okay.
Yeah, we'd love to. Thanks for the heads up. We're always learning different models, so it's super cool to hear how others are describing as they're working with students. Um, so with the models one, we just wanted to bring it back to the model that we just talked about with Stephanie, and kind of talk about whether you're calling it upstairs or the finger part or the wizard part or with some of the newer models. Just all those models have a lot in common. And so we just are kind of saying those things out loud. This is the part where we're just trying to share out loud as you're thinking about talking with students or families, what cuts across those models. And I really want to give a shout out to Dr. Maris. She really helped with my own understanding of this. So appreciate her guidance as we talk about how this model relates to all the other models that we just saw in the poll. So the main thing with all of the models, and they all are really great ways to convey information to kids. It's just that understanding of how something happens is a superpower. So really the idea that us being able to talk about it and give language to it really just helps us feel a little more in control of it, and that can really be a superpower. There's the ideas that brains matter and different parts of the brain do different things, like we just heard from Stephanie. Talking with students, we really like to emphasize across all these models that the brain is integrated and all these parts and pieces work together. Sometimes younger kids or others, they may need reminders about the upstairs and downstairs. They're always working. There may be a little bit more focus to one or the other at different times, but they're always working together and integrated. And what we really are aiming for is a balance, and that's a lot of what we talk about together today. Um, we like to talk with kids and students about these neurological processes are fast and automatic. Um, and so it's kind of that idea, if you put your hand on the stove, would you rather have your lizard brain or your wizard brain in charge? So that one, of course, you think, well, I want my brainstem in charge so that I move my hand fast. Or if I'm out in the yard and a bear walks by, I want that the lizard brain or the downstairs brain to help me get away fast. But if I'm doing a math quiz or am trying to solve a challenging problem with my friends, I really want that upstairs brain. So the idea is just it gives some language to be able to talk about. There's no right or wrong parts of the brain. They're all working in tandem and they help us do and solve different things. I think what we've heard from Stephanie also just it reminds us of the limbic system and the be it the thumb or the little piece structure that she just showed us. Just the idea that we know how that limbic system impacts us and that emotions impact our ability to learn. And I think sometimes sharing that with students can be powerful because they may just not have thought about it that way. There's the idea that brain and neuroanatomy language can help us communicate together. And then just really the things we talked about starting off today with the brain health and coping strategies like limiting multitasking. Um, they're like other things, the more we practice, the better we can get at them. And that these habits really can help us return to balance and really maximize our brain strength. The other part I wanted to mention, this is one that comes up when I'm talking with parents, is just talking about the timing of this kind of brain education. It's just a reminder that kids, just like us, take in this information best when they're more in the wizard brain state or the upstairs brain state. I know myself as a parent, there's always a draw to teach some of this when the student may be having a challenge with emotions. And so it's just my own reminder too that just like us kids and are going to take in the information the best and the with also quite a bit of repetition when they're in that calm state. Next slide, please. So I hand that over to you, Steph.
Hey, thanks. Yeah, I think really important points and to kind of think about, right, that just how complex the brain is. I love the hand model. I love, right, using our models, these little pink guys. I think it's a great way to kind of help, right, in order to kind of understand the complexity of the brain, it's helpful to kind of think about it in these little pieces or parts. And so just like how, right, there's this thought of like left brain does something, right brain does something, half your brain doesn't turn on and off, right, in order to do something. Our brains are always active, just different areas get more activated than others in order to do certain tasks. And so this, even I'm not going to quiz you on this, this is a very complex slide. But the purpose of it with the arrows is to kind of show just how complex these circuits are. This is like a simplified circuit. There's a lot of other things happening at the same time, but just to kind of highlight, right? Like it's not like, right, when I'm planning and organizing, I'm only using my frontal lobe, or when I'm remembering or speaking, I'm not just using my temporal lobe. For like working memory, right, where we see a lot of like a construction zone, a lot of difficulty with kiddos especially, is their ability to kind of sustain attention, right, to pay attention and concentrate on something, and then, right, make a really good memory out of it. And so what this shows is that the front part of our brain, so if we look at the image on the slide, all the way on the left-hand side, the prefrontal cortex, we don't need to necessarily know the name of it, right? But the front part of the brain, we need that in order to pay attention. We have to be able to kind of shut off other distractors and pay attention to the thing that's happening. So like right now, as I talk to you, your prefrontal cortex, or the front part of your brain, is focusing on what we're saying. Then there's a whole lot of parallel processes that happen from that. I'm paying attention, and now it goes into what we call Broca's or Wernicke's phonological loop. Big name, we don't need to know the name, but basically from paying attention, it's now going into the temporal lobe to try to figure out, okay, what is that person saying? And I'm trying to make meaning out of it. Then at the same time, right, it's also going to another part of my brain, my parietal lobe, to think about, has this happened before? Is this similar to something I've known or done before? If so, cool. I'm now going to kind of attach that memory to it, because we like to, as humans, like make meaning out of things. So it's giving us context for what we're hearing. So maybe as I'm talking to you about the brain, you might go, oh, okay, I'm now understanding what she's saying. She's talking about the brain. I'm now going to my kind of memory part and starting to think about, has this been talked about before? What do I already know about the brain, and providing the context? And then also, maybe as you think, I do this a lot, as I think about what someone's saying, I kind of visualize the words or visualize the image. So that means the back part of my brain is now activated, and it's using my kind of visual sketch pad to kind of help organize things. So all these things are happening, right, in order to pay attention. And then it goes, boop, memory file into the hippocampus. So all that to say, right, there's a lot of circuitry and parallel processes happening at the same time. And so if there's like an inefficiency in any of those processes, right, it's going to feel like you're slowed down. There's lots of different points where you can get kind of distracted on, in a sense, too. And so thinking like with kiddos, if we know this front part is a construction zone, it just is until they're, I think, like in their like early 20s. It's just going to be a construction zone for a while. And so thinking, right, if all these things have to happen right in order for someone to actually be able to pay attention, that's a lot of things that have to happen right, and a lot of little things or blips in the radar that can happen along the way that can kind of disrupt someone's ability to pay attention and eventually create a memory. So it's a symphony of circuits. That's how I think about it. And again, I hope you all don't stress out with the names, but the main piece, right, is just that there's a lot of circuits and things happening all at the same time, that it's just like a symphony. You have to have all the different pieces or musicians playing right at the right time in a certain way in order for it to sound nice. Next slide, please. So this is just highlighting, right, the front part of the brain is a construction zone, and the back part, there's actually a lot of things in between there, construction zones too. But these are the two main areas that are construction zones. And so in terms of memory, right, we think again, back to our models, right, the model, and we open it up, and we know from the other slide too, that the amygdala and hippocampus are next door neighbors, or right next to each other, that say if we already have more difficulty being efficient and paying attention because it's a construction zone, and now we're internally activated, or something's happening such that maybe I'm hungry, maybe I'm sad, maybe there's frustration, maybe I'm frozen, maybe there's like a fight kind of response going on, fight, flight, freeze. Something's happening, and now my ability to pay attention and open up my memory filing cabinet, pulling out the correct file and putting the correct file back or in is going to be disrupted because there's so much internal distraction going on. Another way to kind of think about it, even though I am from the era of we have filing cabinets, I still have a filing cabinet, but where I physically put my files, another way to kind of think about this is like, if you have too many apps open on your phone or on a computer, right? Everything gets kind of bricked up. It doesn't want to, like, things freeze, they kind of unfreeze. It's just a really weird experience when that happens. And so it's also very overwhelming when it happens too. You're like, what's happening? So if I have too many apps open in like a window or too many tabs and I can't focus, now my efficiency has decreased and my computer's efficiency has decreased too. So it might be another way to think about it other than just a filing cabinet. But yeah, so again, main takeaways, there's a lot of construction zones for kids. It's not necessarily their fault that they can't pay attention. I know a lot of times there's a lot of kind of pieces to it, right, where there's motivation, and there's a lot of those pieces too that kind of come into play. But just, I think, right, the power in this is reminding ourselves that kiddos have a lot of construction zones, and then thinking about how they've, home environment, how they've learned to kind of cope with things, or even messaging that they're hearing from parents or adults sometimes can kind of exacerbate some of these experiences too. Next slide, please. All right, so we know that a lot of changes can happen to the brain if we don't have access to resources and are trauma exposed. Trauma can be intergenerational. It could be more of like an acute like instance that the child's experiencing. Uh, these all change actually the structure and neurobiology of brains. And just one thing to think too is that, there are critical windows of development. So your brains need certain nutrients. That's why there's prenatal vitamins, right, as you're kind of building the structure of the brain. And so, those are things that have less wiggle room, right? Having the right nutrients at the right time to create these structures. But a lot of times, just as, trauma can impact the brain, so can healing. And so, even though, brains are pretty malleable, and so, we know that with long-term chronic trauma, chronic like malnutrition, not access to safety, that there are a lot of changes in how big the gray or white matter is. Gray matter is most of the brain. White matter refers to pieces that look white, and it's actually all the superhighways or circuitry that's happening. So there are differences in it, but it doesn't mean that it's like that's the way it is for forever. Specifically, people who are trauma exposed or have lower access to resources, that frontal part, it's not as efficient. We call it like an attentional vulnerability. So yeah, as you can imagine, kiddos who are trauma exposed and also have ADHD or a different kind of developmental course, they will have a harder time planning and organizing, and that construction zone of a front part of our brain is going to stay a construction zone for longer. Doesn't mean that they can't do things, just means that it might take longer for them to kind of orient to the task and get things going. Interestingly too, right, we know that the hippocampus, the memory part, and the amygdala, the part that's tied to a lot of emotional experiences, the hippocampus or your filing cabinet for memories actually becomes a little bit smaller, and the amygdala gets bigger. And thinking about why that could be, right? And so there's a lot to say about structure and function, right? That the structure is going to map onto the function of something. And so with our amygdala becoming larger, it's actually trying to be a better alarm system for us, right? Because for whatever reason, we don't feel safe in a certain way, or we've grown up in an environment where we have to be kind of hyper vigilant about things. And so our body's response is, okay, I'm going to create a super sensitive alarm system. But then what happens too is sometimes when the environment changes and there's more supports, and maybe you don't need that super sensitive alarm system, it takes a while to kind of down regulate or kind of dial it down, dial it back, such that you're not, right, kind of hyper vigilant all the time, or have bigger emotions a lot of the time. When you have also reduced resources and trauma exposure, the allure or the funness of rewards and motivation is not the same. So that kind of points or implicates that the kind of the dopamine response system is slightly shifted. Again, it doesn't mean like it's damaged beyond repair or anything like that. It just means like this is something that's happened and it might take a while for the healing process to occur. And yeah, again, too, right, just to kind of reiterate with a little construction zone person, kids have lots and lots of construction zones. The cool thing about brains is that they're super plastic and malleable. And even though, right, we have kiddos or maybe ourselves too, who have grown up in these environments, it just as these, lack of resources, trauma can impact the brain, healing can also. Next slide,
Stephanie,
please.
I just wanted to let you know we've had a couple questions come in that relate to what you just mentioned. So I wondered if we could
Yeah.
talk through those right now. One asks, can you describe the impact of neural-based diagnosis in addition to the development of brain construction zones, such as with ADHD? Is this similar to will be under construction more as mentioned in the trauma slide?
Yeah, that's a great question. Thank you for that question. Yeah, how I kind of, hopefully I'm answering it to track on to what you're asking. Yes, so kind of the messaging that I provide is more of like, it's an area of construction, right? It's a construction zone. It might take a little bit longer to construct, and we might need some additional tools. So the additional tools, to kind of think about would be, like more, right, more structure or more organization, or more kind of like scaffolding around that. Um, but yeah, definitely more different types of construction tools would be helpful. And then also it's just going to take a little bit longer.
Thank you. That's super helpful. A second one that we received was, can you explain what is happening in our brains during a panic attack? Why would a panic attack all of a sudden come on? Does your brain associate fear even when you don't realize it?
That is a great and very insightful question. Yes. So we don't have to necessarily have the thought, oh my gosh, this is super scary or super stressful. Our body can sometimes just know that somehow it is stressful and it kicks on this whole fight or flight response. So it's the exact same structures involved in terms of like it's the amygdala. And for whatever reason, it could be um environmental, right? There's sometimes when our body hangs on to a lot of different kind of experiences in a way, right? We physically experience stress. So sometimes it's kind of like when we hit our own stress threshold, it's enough to kind of kick this whole fight flight response on, and our amygdala just kind of sets up and starts going off. And I guess the silver lining is that panic attacks rarely last longer than 30 minutes. Your body can only sustain this active, like acute response for about 30 minutes before it has to re-up. So silver lining is that it will end. It will not go on for forever, but it is it's very not fun to have to experience panic attack. So things like the self-regulation strategies, grounding, um, like playing I Spy with the environment around you, doing grounding activities, even when you're not having an active panic attack, but kind of across the day, can actually help dial down that stress feeling or response that your body's ready to do. And actually can kind of give you more buffer or bandwidth before your body flips into that fight, flight, freeze mode.
Love this question too. So we might be able to share a link or something similar in our resources. Just give us a little time, and we'll share some of that as part of the debrief. Um, Another comment was just the idea of adding lack of physical activity to the trauma exposure and reduced resources that were just discussed.
Yeah, so in terms of like the yeah, like reduced physical activity, it's definitely a risk factor for brain health. Um, Physical activity helps even a lot of it's like one of the behavioral strategies for kiddos with ADHD or attentional difficulties. It's a great way to kind of help recruit the ability to focus after you kind of can walk around or get blood flowing. There's a whole signaling cascade in your brain. Brains love being physically active, and there's a lot of kind of endorphins and things that help can help us focus and also like reduce physical pain. Interestingly, um, that physical activity can do. In terms of brain health, just kind of go off on a tangent real quick. Our brains are super fatty, and that's just kind of what they're made out of. But within that brain, there is a super highway of plumbing, and that plumbing helps us get all the blood to where it needs to go. And if over time, so maybe not necessarily for the kiddos, but for maybe us, um, over time, if we are not physically active, if we maybe don't make the best food choices across time, like we choose all the fun foods, I'm definitely guilty of that. We can end up with higher cholesterol, high blood pressure, all those things. And even though it might not seem like a big deal on the surface level, that can all impact that sensitive plumbing that's inside our brains. And so over time, it can actually lead to like having more difficulty thinking fast, more difficulty planning and organizing. So we can, as we age, we can end up with more construction zones again because of just, if our brain can't get the nutrients that it needs.
Yeah, there's really some amazing research coming out around brain health and healthy lifestyle, physical activity, and diet, and all that. It's really fascinating.
Yeah.
Uh, the next question relates directly to the slides and just asking with the bullet point reduce responsiveness to rewards and motivation. Could an example be provided around what that might look like?
Yeah, so I think there's a lot of complex things happening in terms of the reduced rewards and motivation. Um, so, right, physiologically, we know that maybe the signaling can kind of not be as intense. But if you think about all the different like psychosocial stressors that can also come into that. So, say if you're a kiddo who has attentional difficulties, and maybe that's because, right, developmental plus not having enough resources, being trauma exposed, those are all a lot of things for a kiddo to navigate. And then if they're being told, you don't pay attention, you can't complete tasks on time, like there's a lot of talk around what you can't do versus what you can do. That in of itself can kind of not feel intrinsically motivating to a kid. And so it's kind of like part of this like experiential piece of like, oh, like this is not really motivating. Why bother? Why even try if I'm always going to be told, right, you should do better, you could do better. Paired with actually some of these receptors kind of reduce for experiencing like the like dopamine response and stuff because there's nothing rewarding about this situation in a sense. That kind of the experiential piece plus the brain chemistry shift kind of down regulates things or decreases your ability to kind of really experience joy in a sense too of like, oh, this is fun, I'm going to keep doing it. I can definitely think of better examples too offline, and we can share that. But that's kind of like the studies out there that talk about reduced responsiveness to rewards and motivation kind of have that in mind. There's like it's like a twofold. Structurally, something is shifted, and also there's a like a psychosocial environmental piece to it that's also creating this negative feedback loop.
Thank you. That's really helpful, Stephanie. I really appreciate the further information. A final question was or comment was just reflecting that in this digital age, just some of the stresses around that that may also impact some of what you just shared around just changes in the brain and how the digital part may impact our children.
Yeah, definitely. And we can definitely, I'm sure, talk for a long time about all the how the different like social media, digital age, all these different things stress not only our brain, even just thinking like on Zoom right now, seeing our face, there's studies on it in terms of like why is Zoom so tiring, right? It's because I'm staring at my face the entire time. And then also if you think about the eye contact piece, my eyes might not be lined up with your eyes are. And so there's this extra like cognitive effort happening trying to, find where your eyes are at. So I think it's just interesting to think about how tiring it our digital age can be too, even if right we have the best intentions of things.
That's an awesome point, and um, we have some resources from our Heartland Telehealth Resource Center around the Zoom fatigue. That might be something useful that we share at the end of this presentation, just around some of the brain health part that goes along with strategies to address some of that.
Yeah. Yeah, the other thing too, I think, just with all this information, I really do hope that, I think we probably have all had a time in our lives where we felt super stressed or kind of noticed our own kind of cognitive lapses, like difficulty with paying attention or memory. So I do hope too that, as a takeaway that one, this feels validating, right? That you're not alone in this experience. And also it's like, um, that no, this has happened, like happens to a lot of us. This is not you becoming crazy, right? We're not going crazy. It's nothing like that. I know sometimes it can feel that way, or that's the language that's being used. But it's like, nope, these are human experiences because we're all human, trying to human together. Next slide, please. All right, so we kind of talked about this a little bit, but I like this graphic. And in our resources, we also there's also a link to, there's a psychologist actually in Northern California, and she creates a lot of these like kind of cartoon illustrations and how to explain everything from like ADHD to attentional difficulties to dyslexia to autism to school age kiddos for like teachers and parents. I think it's a great resource to have. But just thinking, right, with with our knowledge, there's different brain parts doing different things. We know how impactful stress can be too. not only for us, right, but for little developing brains. Just thinking how much, right, acute and chronic stress can really impact the brain, but so can healing. We all experience cognitive lapses and we all are humans, so we tend to kind of over attribute these cognitive lapses to one thing, but also, trying to start getting curious about like, why am I having memory difficulties today? Why is it hard to pay attention? Chances are it's probably like the perfect storm of stressors going on, and it's not just one thing. Um, we can, in terms of we can help the little ones, right, in terms of using the brain language to kind of help explain or help support regulation activities. Helping adults in our, say, in our own lives or children's lives, trying to get curious about why something's happening. And, even though kiddos can't necessarily control environments that are happening around them, right, we can definitely support them with skills in their response. So I like this little cartoon, right, because a lot of times you can think about the little kiddo here, right, being told by others, or maybe they're not saying it this way, but maybe how the adults say things, this could be the takeaway, right? Like, I'm dumb, I'm lazy, I can't do it. Versus right messaging around like, oh, my brain's different. And that's pretty cool. Maybe I have a couple more construction zones. Maybe I need some more tools in that construction zone, or maybe I need some more manpower, right? But trying to kind of focus on, right, what can we do versus what can't we do. All right. And then other things too, like maintaining classroom structure. I know you all have a lot of structure in your day, but it's not just an agenda for the sake of having an agenda. Like every time we do the little like weather check-in, we do like a self-regulation check-in, we're actually modeling how to kind of impose a structure to our day and how to also circle back and check things off. And that's going to be a super important lifelong skill. I know from when I was in kindergarten, I remember doing like daily weather check-ins, daily like kind of like, how are you feeling kind of broadly. We definitely didn't have all these like the terms that we have today, or at least I wasn't exposed to it growing up. And but I've still used that kind of structure in my day-to-day, like a self check-in. I mean, it's not as detailed as it was in kindergarten, right? But self check-in with myself, make a task list or my agenda, and then as my day goes on, I check things off. So that has been like a protective thing for me across time. So even if sometimes, right, there's lots of classroom behaviors that are kind of going off the rails and it's internally frustrating to us, kind of thinking about like, right, just by being there, by being that kind of calm, supportive individual, even though it might take all your energy that day to be that calm, supportive individual, and then relaying things back to that schedule or that agenda is going to be super protective and helpful across time. Next slide, please. So just again, thinking, right, because of all the construction zones, kids have a much harder time multitasking. And so we just wanted to share some of these ideas, right, with this idea of the construction zone. But from our friends in Coffeyville, they were gracious in letting us share this with you. But just, so their mascot is the NATOs. And so this is a zones of regulation that they use with their kiddos. And so I think with our own mascots or kind of where we are in our areas, this might be a neat way to kind of have it like a school spirit based, check-in and helping kids kind of using that language with check-ins, right? Or maybe how they're feeling during the day to communicate big feelings, right? And then also too, again, I know we kind of talked about it, but ways to talk to kids and parents, right? Zones of regulations. If we can get parents to also, I know this is easier said than done, kind of help adopt the same type of regulation talk, right? You now have continuity in the classroom and also at home. But also just thinking, being mindful of, right, like, what are kids hearing us tell adults? What are adults telling the kids? And just thinking, right, like, if a kid has a construction zone about attention in that frontal area, maybe someone's going to say, he just doesn't pay attention, right? Whereas the kid's perspective might be, this is so boring, because if we have an ADHD brain, you probably think about things a little bit different, and that's pretty cool. You're going to be able to, as a professional, probably make connections that other people can't make about how two things are alike. And at the same time, right, trying to figure out, okay, so this is an area of construction you only like to attend or focus on really, really cool or interesting things, trying to kind of refocus like, okay, how can we maybe incorporate some of what that kid likes to do with the trade-off of doing some stuff that he doesn't want to do? If someone says, right, oh my gosh, they're so disorganized, right? Maybe even from the kid's perspective, it's really overwhelming. There's too much going on. Maybe if someone says, right, he procrastinates, kid's response might be like, I just get it done. Or right, someone's perspective of like, oh, they can't handle no, right? Maybe from a kid's perspective, it's more of this unfairness or unjustness occurring. So, right, there's a lot of different perspectives and ways that we can tailor messaging, tailor language, self-regulation behaviors to the child's interests, and also to maybe language that might map on or might like highlight, right, the parents' experiences too. Did you have other points that you wanted to add, Evelyn?
No, I really I love the zones of regulation. Um, I think with students too, we can tailor some of that to interests, be it sports or music or what gaming, whatever really is in the students' high interest. Sometimes we can use some of that same language when we're talking about these same concepts about feeling intensity. Um, but I appreciate what you said about um, trying to think through when a kid says it and when an adult says it, kind of how that may line up.
Yeah. All right, next slide, please. So we've got lots of resources for you and different ways to kind of help bright kids talk about some of these things. There's Jane the Brain through the NIMH, and they have lots of videos about talking about stress, how to talk to kids about stress. It's kind of kid-friendly language, which is awesome. There's different books. So there's, Your Fantastic Elastic Brain, a little bit definitely for a little bit older audience. But it's kind of cool because again, it comes at everything from this like a growth mindset or right, kind of like what makes me unique and how's my brain unique, and not so much messaging about right like the more the negative aspects or things that you can't do, but thinking about, well, your brain is pretty elastic. Maybe you have some construction zones in some areas. How can we help kind of bolster those things? And again, just the thought that kids have a really difficult time with multitasking because of those construction zones.
I'm reminded of our question before, Stephanie, about the digital age. The Jane the Brain frustration video is about getting frustrated with um, being on the tablet and not doing as well as you wanted on a game. And so I just sharing that some of the Jane the Brain is pretty relatable and talks about, well, what's a different decision that we could make and have a better outcome. So anyway, they're very cute.
Next slide, please.
We're getting some in the chat too, just that Julia Cook does Bubblegum Brain
That's great.
in those books. It sounds like several of our attendees really like those. So that's
That's
awesome.
awesome. Yeah, definitely. Please, thank you. Share those resources. We can get them out to others too. And just thinking too, right? I think this kind of also is a great example of the question that came up earlier about panic attacks. Right, there's a lot of stressors that are happening just across our lives, and especially with holidays coming up too, right? It's just kind of one stressor after another. And thinking about, right, just how these stressors can not only maybe we have a thought, maybe we don't have a thought. We don't have to always have a thought, but everything kind of physically and mentally impacts us. We are mind body connected creatures. And so I know when I personally get stressed, I clench my teeth and I get a headache. And so that's my kind of mind body connection right there. So thinking about, right, maybe for some of us, maybe it's like our shoulders scrunching up. There's different kind of physical tells, right, of stress. And just thinking about how, right, when our bodies physically hit a point where they're kind of like, I'm tapping out, there's too much stress going on. It can manifest as a panic attack. It can manifest as a lot of aches, pains, other things. And so, being in the roles that we're in, right, it's, we're not only trying to self-regulate ourselves, but also help kiddos learn how to self-regulate. And just thinking about, right, how by us modeling out loud about how like, right, oh, I can't pay attention right now because I'm really overwhelmed, right? Using those kind of examples can help kids also learn that language. And also, make it not feel like a scary unknown thing when these big emotions happen or why I can't focus, right? It's not, no, like no one's going crazy. It's just our brain's overwhelmed physically and mentally. And also too thinking like we all mess up. I know I mess up every day and on something. And so thinking about, right, like we can also model self-talk. So like, okay, when I mess up, do I talk to myself like my best friend or do I talk to myself like my worst enemy? Chances are a lot of times we talk to ourselves or hold ourselves to a harsher standard than what we would do to others. So right, kind of modeling how to bounce back from mistakes too is also a great skill for us, but also a great skill for little ones. Also being mindful about how we incorporate support and routine into our own lives, how we replenish our own battery, how do we recharge our own battery, and how to limit multitasking because overall we want to reduce the brain power cognitive fatigue going on. Next slide, please. So in the chat box, what is one thing that you'd like to put into practice until next session? Yay, these are great. Yay, grounding, construction zones. I like it. Yay. And definitely too, just, as you try some of these things out, um, it's going to be awesome to, kind of just for us to know too, if you guys want to share next time about, thinking ahead, like, okay, well, when you try these things out, what's working really well and what's not working so well? Because we definitely want to help brainstorm the stuff that's not working so well or how to adapt it. Because chances are maybe someone else in the group too found a strategy and how to adapt it for maybe the same problem that you're experiencing. So yay. Thank you for sharing. All right. Next slide, please.
I'll just share, Stephanie. We see so many great answers in the chat. Some of them are already speaking to this next thing that we're talking about putting the brain model into practice, be it this model or some of the other models that we talk about. So Christy's going to share with us just a little bit. We'd love to see just ideas of how you're using your brains to help all of us think about how we might use them too.
Yeah, thanks to everyone who participated in the pre-survey and opted in to receive the brain model. We noted everyone who said they hadn't received theirs yet, and we will definitely check into it. If you haven't filled out the pre-survey but want to, so that you can receive the brain model, email us and we will send you the link. And with all of these questions, we definitely appreciate your patience and we will get it worked out for you. If you have received the brain model, we'd love to see a photo of it in action. So if you, it could be a photo of how you're using it, where it's located in your office, or take it, on an adventure kind of flat Stanley style. You can add a caption that shows the city or add a description of how you use the brain model in your work. It's totally up to you. But if you click on either the link that is in the chat or scan the QR code, you just have to click add to board and you can upload an image of the brain. Just a note that entering your email is optional. It will ask for your name though. So anyway, we look forward to seeing your photos and you can email us with any questions or if your photo isn't posting.
Kind of part of the idea was a little bit like the flat Stanley idea that I imagine folks have encountered, just the idea of sharing where the brains are being used, and again, just helping us all think of other ideas.
Yeah, so key takeaways, right? Different parts of the brain have different roles, and we need all these parts in order to function together in order for things to work the way we want them to. Stress and emotions can impact attention, memory, and learning. And we can help kids and their parents, in parentheses, kind of help think about their brains as construction zones. Well, thank you for attending, and hope to see you December 5th.